End-to-end slice demonstration applied to an Industry 4.0 use case. This demonstration is about how to guarantee the quality and proper functioning of critical services in an environment where multiple industrial processes are sharing the same network infrastructure. Particularly, for this demo, both a video surveillance stream and an industrial control traffic have been categorized as our critical services. The aim is to ensure that this services network traffic remains stable and with the appropriate quality levels all along its route, which includes, of course, all the different network segments that can be expected in a mobile network infrastructure. And what is more important, to ensure that our critical transmissions are not affected by the presence of any other network traffic belonging to non-priority services. The 6G BRAINS architecture, divided in different planes, can be instantiated for different purposes to create multiple functional architectures. This demo focuses on work package files, especially task 5.2 and part of task 5.1 and 5.3 to show our vision of an end-to-end network slice. In the monitoring plane are all the modules that provide information about the flows traversing over the network segments and the infrastructure topology. The control plane contains the intent-based API to unify the communication within the network controllers that will insert the network policy rules for slices. In the data plane, several programmability agents such as traffic control, OVS, and NetFPGA allow network policies to be configured and adjusted as appropriate. Modules located at the management plane allow network administrators to configure and deploy network slices by accessing the Slice Manager dashboard. The functional architecture presented lies on top of a mobile infrastructure with multi-tenancy, virtualization, and containerization capabilities. The demo will show how to create an end-to-end slice for the target critical services. Let's see then the different steps involved for the configuration and instantiation of an end-to-end network slice. First, the monitoring plane reports the topological information of the infrastructure and the current network traffic information. Then, a network administrator can access to the Slice Manager interface to start with the configuration steps. To this end, the Slice Manager will notify via a common interface its intention to configure or instantiate a new slice in the system. Finally, each network controller will program the required network devices that are allocated in different points of the infrastructure. At the UWS premises, a realistic testbed emulating an industrial environment has been built to empirically demonstrate the applicability of the proposed framework. There is a mobile phone injecting the critical services traffic into the network. We also have built the RAN segment. The traffic is also passing through the edge network, the transport network, and the core segment of the infrastructure. Also, we have built a traffic center to emulate and reproduce the congestion in the network. There is a display connected at the endpoint of the transmission to verify the end-to-end. Finally, the Slice Manager dashboard from where the network slices will be configured, instantiated, and monitored. The objective is to secure our critical transmissions all along the different networking points in the infrastructure. In this initial and ideal state, without the presence of congestion, the video plays smoothly and there are no packet losses. However, this can quickly change when background traffic is injected into the network emulating other industrial processes, and the network becomes highly congested. Let us proceed to instantiate a new network slice by using the Slice Manager dashboard. Thanks to the topology inventory agent, the whole infrastructure, including all the programmable network points, are available to reproduce an overview of the entire system. The next step is to select the scope of the network slice, meaning the start and the end point. In this case, from the user equipment to the core segment. Automatically, the data path route is calculated and it will present a routing preview from where these 2 points communicate with each other. Note that every single spot along this route means a different networking point that needs to be programmed to guarantee the quality of service of the critical transmissions. Once a network slice for our critical services has been instantiated, results are immediately evident. The service's performance has been restored. Even in the presence of congestion, the network requirements of critical industry services have been met from end to end, across multiple network segments and with changing traffic structure due to its encapsulation and tunneling mechanisms.